In this video, we're going to look at modelling with trigonometric functions. Example 1 says the cabin pressure P in pounds per square inch psi on an aeroplane at cruising altitude can be modelled by the equation P equals 11.5 minus 0.5 sine t minus 2, where t is the time in hours since the cruising altitude was first reached and the angles are measured in radians. Part A says state the maximum and minimum cabin pressure. So let's take a look at this. So we can first of all write down our equation that P equals 11.5 minus 0.5 sine t minus 2 is our function. Now don't forget, because this is a minus, if I have a minus value, the minus times the minus will become a plus, so that will be when it's the maximum pressure. So at maximum we're going to make sine minus 1, as in sine t minus 2. So we're going to get 11.5 minus 0.5. Now the minimum value of any sin x graph is minus 1, and that's going to give me 11.5 plus 0.5, which gives me 12. Now in the same light, to find the minimum pressure, we need this to remain as a minus, so that's going to be P equals 11.5 minus 0.5. Now if this is 1, we're going to get P is 11.5 minus 0.5, which is going to be 11, and the units are psi. Then part B says find the time after reaching cruising altitude that the cabin first reaches a maximum pressure. So in order to do that, we're going to say, well, we know it reaches maximum pressure at 12, so we just calculated that. So that's going to be 11.5 minus 0.5 sine t minus 2 equals 12. So we can solve that equation. So minus 0.5 sine t minus 2 is equal to 0.5. So we can say sine t minus 2 equals to minus 1. Now from the sine graph, we know that minus 1 occurs at the following values. So we get t minus 2, and that will occur first at minus pi over 2 and 3 pi over 2. But don't forget, we're going to add 2 to this. Now don't forget that sine t minus 2 must be between minus 1 and 1. So if we add 2 to it, so we're going to do 2 minus pi over 2. Let's see what that gives me. So we need to be in radians mode. So alpha minus, here we're going to go to change the mode, make sure we're in radians mode. So we're going to do 2 minus pi over 2. That gives me 0.429. Now if you're not sure how to change that to time, there's these buttons next to the minus sign which have like a little comma there and a degree. Press that and that tells you it's 26.45. So we can say it's approximately around 26 minutes. So you can use that button to guide you there. Then part C says calculate the cabin pressure after 5 hours at a cruising altitude. So what we can do now is say C. So you do part C here. So we're going to say P equals 11.5 minus 0.5 sine. Now instead of t, we've only got 5 hours. It's 5 minus 2. So if we do that on our calculator, that's just going to give me 11.43 psi. Then part D says, find all the times during the first 8 hours of cruising that the cabin pressure would be exactly 11.3 psi. So now we're going to do that. So we're going to say part D here. So we've got 11.5 minus 0.5 sine t minus 2 equals 11.3. We can solve for that, and if I solve for that, I get sine t minus 2 equals 0.4. So now we can arc sine that. So arc sine of 0.4. So on our calculator, arc sine 0.4 here, and I get 0.41. And then don't forget we need to use the cast diagram. So we're looking at sine. So put 0.41 radians there, 0.41 radians there, ASTC. The next solution is pi minus that. So t is pi minus 0.41 radians, t minus 2. So we're going to do pi minus the answer. So I get 2.73. So 2.73 and so on. So we can list these out. So we can say t minus 2 is going to be 0.41 followed by 2.73. So if we add 2 to it, we're going to get 2.41 and 4.73. But if we used that button I showed you on the calculator, you would get your answer as follows. You would get it as 2 hours and 25 minutes followed by 4 hours and 44 minutes. Here's a question for you to try. You can pause the video, and when you're done, I will go through my work solution. Okay, so in this question, we have an equation that says t is equal to 225 minus 0.3 sine 2x minus 3. So we need to state the minimum temperature of the oven. So we can do that as follows. We can say when sine x is going to be 1, we're going to minus that value. So we can say t is going to be 225 minus 0.3 times 1. And then we'll get a value of 224.7 degrees Celsius. Then part B says, find the times during the first 10 minutes when the oven is at a minimum temperature. So we can say that 225 minus 0.3 sine of 2x minus 3. Don't forget our range is between x is greater than or equal to 0 but less than or equal to 10. So our new range is going to be 2x minus 3, which goes from minus 3 to 17 is our new range. So we're going to write the new range, right? So now we can say that sine 2x minus 3 is equal to 1. So we could solve these. So we get the following values in radians. Pi over 2 radians, 5 pi over 2 radians, 9 pi over 2 radians. So now we can say that if we were to solve that on our calculator, we'll get 2.285, 5.427, 8.569. Using that same button I showed you before, we will get the following values on our calculator. We'll get x is going to be 2 minutes 17 seconds, 5 minutes and 26 seconds, and then we're going to get 8 minutes and 34 seconds. Let's write it down. 8 minutes and 34 seconds. Now part C says calculate the time when the oven first reaches a temperature of 225.2 degrees Celsius. So we're going to solve a trig equation here. So we're going to say C is the following. We're going to get 225 minus 0.3 sine 2x minus 3 equals to 225.2. We could rearrange that to give me sine 2x minus 3 is equal to minus 2/3. So we can arc sine that now. So we can say arc sine minus 2/3. Make sure you're in radians mode. Gives me minus 729, right? So our first solution is minus 0.729. So we know that sine is negative in the third quadrant and the fourth quadrant. So this gives me minus 0.729. But to get the next solution, remember, we need to do minus pi plus that. So we're going to do minus pi plus 0.729. And that will give me the following, which is going to give me minus pi plus 0.729 so we get minus 2.41. And the reason why we had to do that is because of our range. Our range starts from minus 3 all the way to 17. So in fact the question states that we need to find the time when it first reaches it. So in order to, when it first reaches it, will be minus 2.41, what we just found. So we're going to say that when we solve that, we can say that if 2x minus 3 equals minus 2.41, then x is 3 minus 2.41 divided by 2. So now I'm going to do 3 minus 2.41 divided by 2. And that will give me 0.295 approximately. And if we were to convert that into seconds, we can just press this button here and we get approximately 17.6 seconds. So approximately 17 seconds. So approximately 17.6 seconds.